Hi. In AutoCon, we presented a new feature in Infrahub called Path Traversal. The ability to see the path between two objects in the UI, where one can include or exclude kinds, or can define the maximum depth or the maximum path that he wants to see. And people loved it. They loved it so much that immediately after we showed this, follow-up questions came along asking, can this be used for impact assessment or firewall compliancy or drain scenarios or physical and logical topology evaluation? So I took those questions away and had a sparring session with product management, in particular Wim, one of our product managers, and he gave me an interesting idea, which I pursued and to my surprise actually works wonderful. So in this session, what I want to show you is how you can use Infrahub capabilities, native capabilities, to use the path traversal as a check for any change that you are doing. And it's very dynamic and you can do any use case that you want. But before I show you in this demonstration how everything works or what I have built, I want to go 2 steps back because I don't know in which level you guys are that are watching this video. So I want to talk about what Infrahub is and what Infrahub provides. And I want to talk about path traversal because I'm not sure if all of you have played around with path traversal. And hence I want to cover those 2 cases first before I dive into the demo and explain what I have done. So what is Infrahub? To answer this question, I like to take the NAF, which is the Network Automation Framework. It's a reference architecture which should help all of us in the field to gauge basically where application in the network automation space fit in. Infrahub fits in the intent state and fulfills the job of the source of truth, like Netbox and others in that domain. How we do things, though, we try to do it differently than others. And you can see it on the right, which I will cover in the next slides, but it's basically unify. We try to unify any kind of data. We give you the complete control, no matter if it is day 0 to day 2, that you can change the data, but also the relationship of the data. We integrate with every ecosystem that exists and also automate things to generate more data and automation inside Infrahub. So let me dive into all those subjects a little bit. So when we talk about unify and control, what we mean is, yes, we unify network and infrastructure data in our graph database, but not only. You decide what modeling you want to do. And that's the key here. It can be services, it can be business logic. And I always like to take the analogy of you can even model restaurants if you want. But the idea is that you model whatever you want to model and in a YAML-based way, and then it gets computed in a graph database accordingly after you imported it into Infrahub. And that's the power of Infrahub, the flexibility to choose what modeling and how it should look like. It's up to you. Then regarding change, we believe that change is not once, but should be done continuously in a very controlled manner. That's why we use a Git-style approach where you can review a change in data and schema that you have designed, the database that you have designed, and redeploy a new schema or data as you wish. You can review it, you can do CI/CD on it, and it is a very controlled way for you to change the data and the database accordingly over time. When I talk about integrate, then we integrate with the executor layer and the orchestration layer in the network automation framework, where the orchestrator calls our APIs, we mangle data, artifacts, we create new data or whatever the orchestrator needs, and then we send a webhook for the orchestrator to collect, or the other way around, the executor as well. We tell, listen, this artifact for this Cisco device is ready, please collect it, and the executor takes it. But not only that, we of course have the presentation layer where we have an UI, where we have the Python SDK that you can interact with. We have our GraphQL and also our skills. if it is the Infrahub skills for the AI agent to use, or our Infrahub spec kit accordingly. So this is the powerful of our integration with other ecosystems around us. And last but not least, we take data that is existing in Infrahub and we can manipulate it to create more data. So let's say you have 2 spines and 4 leaves, and that's the only data that you put in. The business logic that you can create in Infrahub in Python code is to say, okay, with that data, I create now the physical topology, that is the physical cabling, the IP addresses, the VLANs, the VXLANs, the BGP session, all these things that you will need for a data center will be done automatically in Infrahub as it gets executed and consume those 2 data points accordingly. And this data and this information can also be used for checks and transform to create artifacts for the executor, orchestration, and to use accordingly in different systems. So we have data, we create more data internally, and that can then be used to do other things like CI/CD or send it to somebody else to consume accordingly. So what is path traversal then? What we brought to the table is 2 things in our new release. One is the path traversal, which basically talks about a source and destination object and everything in between. So if you have an object, a location, and another location, you can see the devices, interfaces, BGP, whatever, the relationship between those paths, and that you can see visually. The other thing that we brought to the table as a feature is the reachable nodes, basically saying, okay, this source, what are other things dependent on this source node? And all of those 2 things are completely read-only. They are permission safe. You get a visual topology that you can see that as well. It's branch and time aware as well. Let's take the path traversal, for example, looks the following. So in this case, you see there's an association between a source location, which is United States or country in this case, and device ATL1 core 1, right? And then you see the location, and you see the path where you see United States has a path to ATL1 and ATL1 core 1. But not only, and you can see different paths. So for example, if you want to reach ATL1 core 1, if a different path, not the shortest one, you could go United States to order 1, to order 1 core 2, to AS64496, and then you have an association to that. And that's basically the path traversal. You can see everything, you can limit it in what you want, and it's live and read only and branch aware. And then, as I said before, with the other feature is dependence, right? You can see source and target kinds, and you can see which dependencies are for this given source. And you see many of them, for example, for ATL1, right? So edge 1 is dependent on ATL1, core 1, leaf 1, and so on and so forth. And hence, if let's say I want to have a change to delete ATL1, I could only do that if I delete all the other associations accordingly. So those are the 2 features that we have provided in the backend, and we're exposing it as a virtual explorer in the UI. So now, if you look now with those principles that we discussed about what Infrahub has and what path traversal is, we come to the point where if you take the principles of Infrahub, where you can use the backend for checks, then the only thing that we need is an ability to expose or to define rules to assess against the path traversal in such a manner that the check can use to check against. So let me take a topology first. Let me talk about the topology that might help to visualize it a little bit. Let's say we are having the following topology and we want to assert the following. I want to assert that ATL1 edge 1 can reach JFK1 edge 1 via 64496 and the same for DFW1 edge 1. But we want to assert and make sure that ATL1 edge 1 cannot reach JFK1 edge 1. So now to do this, it's actually relatively simple in Infrahub. What I have created now is a schema, a unify way to represent a rule where there is constraints attached to it. As I talked about it before, Infrahub has the ability to create any kind of data modeling that you want. In this case, a model reachability rule, which has constraints attached to it. And I have defined a source and destination as inputs, the same thing, the max depth and the max path. And in the constraints, I define, okay, where should it go? Which reachability should it have and which reachability should it not have? Now, regarding control, a different user, let's say a network engineer, who does not have any automation experience, does not need to even worry about the automation of the check, or does not even need to worry about the rule set whatsoever. What he does is to create a proposed change for whatever he wants to change in the intent. And as soon as it is a proposed change with the given intent data in there, then the check goes ahead, the automation piece goes ahead and uses the rules that I have defined with the constraints and looks into the path and see if what verdicts he can deduct out of it and either passes or fails for those given checks. And that is all in product today. I will give you even one step further. The automation piece is programmed in Infrahub internally. This was me as the automation specialist. And in the demonstration soon, I will log in as a network engineer and show you how I'm doing a change accordingly. The operational team already defined those rules in the network topology that I have already described. And I will also log in as an admin of the operational team later on to show you what rules we can add. But so that 3 different kind of teams, and all of them are doing something else and have different constraints. And with our ability of RBAC, of course, you can do that very easily. So a network engineer, to make it clear, has the ability today to do this change without worrying about if he has any impact or anything. The operational team can ensure that there are constraints and rules that are set in stone that the network engineer cannot change no matter what. And every change a network engineer does will go against those rules. So what I will do is I will log in via Sophia, which is a network engineer, and we'll do a change. I will try to do a proposed change where I just change the description. In this case, the rules and the constraints should not fail because I'm not changing anything that is related to the topic. Then I will go into a Chloe and try to change the ASN 8220, which then if I open proposed change, I'm expecting to see a fail. And then as an administrator of the operational team, I'm going to log in and change or create a new rule, let's say, that makes a max depth of 1 to show you that it will change the number of checks, and that if I put it into the main branch and the production, that then all other users then down the line will need to adapt their changes accordingly to fulfill those constraints. So let me go to the live demo. What you see here is Infrahub, and I loaded some data in, and you can see you have device here, which are loaded already in. And also what is the most important piece is the reachability check that I have created. This reachability check has first the source and destination. It has a dedicated name for this rule. It has a description, and it has a definition of max depth and max path, and of course an enablement flag. If I click on this, please see the source and destination, right? This one, ATL1 edge 1 and DFW1 edge 1 should be reachable via AS64496. And that's what I defined as a constraint. And the constraint is nothing else than hop kinds that I defined here, the attribute name and the attribute value that I want it to have, that the check uses to check against. Now, if I go back and I go to the other rule, it looks a little bit different. Here now, I have one rule, again, also max depth of 3 and 50. And this constraints is now I have one forbidden path. It should never reach it via 8220. And another one which is required, which is 64496. And this is it. So now I have reachability rules that are defined. And that's as an operator, as you can see, I have defined it already. And now I could add another rule, but let me log in with another user. And let me log in, as I mentioned. And now you can see that I don't have any reachability. I cannot add anything. I cannot change anything. And that is on purpose, because that's the idea. I'm now a network engineer, Sophia, who is only allowed to create a new change in the network topology, right? So this is the network topology. And if now I go ahead and create a branch, again, talking about control. So now I want to change as a good user. I'm creating a branch. I don't want to change production immediately. I want to change it in a branch and check against it. So I'm opening a branch. I'm going to go to ATL1, edge 1. And now I'm going to I want to edit this description. So let me just put something like description, okay? And save. So please notice, again, I'm in the branch. In main, if I go to this, nothing has changed. So the intent in the main, in production, is the same. And I, as Sophia, am in the branch and doing those changes. After I'm done with this change, I've done the description, I'm opening a proposed change. So now I'm opening a proposed change. And let's give it a good name so we can later identify it easily. I don't know. Let's just say something like that, maybe. No, you know what? Let's make it a bit shorter, maybe. Something like that. Yeah, let me copy that. Okay, here we go. All right. So now I have created a proposed change. What I should see in my data is that I changed the description and main has not changed, which is exactly how it's supposed to be. And now in checks, I should see the checks running and they are finished as well. So me, as a user of network engineer, I just see and say, okay, check is green, I can merge it. But what does this check mean? It's a reachability assertion which checks, okay, there's a rule called ATL to JFK via S64, which all passed. It passed this is wonderful. And also DFW, which passed as well. I, as the user, can even look at this, and I can look at this and see how it actually presents. And indeed, right? So I can see that ATL1 edge 1 goes over this, and JFK1 edge 1. Okay, wonderful. And I can even go and filter a little bit further and do a lot of other things as well. Now let's go to Chloe and log in as Chloe and do a proposed change that is a bit more, how can I say, more impactful. But Chloe, well, does not know about it yet. So now I'm again logged in as a network engineer, and different network engineer that does a different change. Now again, same network engineer does not have the ability to do any rule change. I cannot change the constraints, nothing of that kind. And now, however, the rule that I'm going to create, first of all, let me create a branch because I'm a good network engineer and I understood the concept of software engineering. And hence, let me create a branch to do my change. So now I'm this branch. And if I now I'm going to go and edit and change it to 8220. Okay? I'm changing that AS. So now the expectation is of the check, if I have a proposed change, as I change the ASN, now it will fail because there must be an assertion. There is an assertion that says that I'm not allowed to reach another DFW1 edge 1 via that, and hence it will fail because there is an association on the other side with that ASN. So let's see. Now me as an unknown network engineer, I have done the change. I will go here as Chloe. We'll give it also a good name to visualize it down the line. Let's say something like that. Maybe that is a good name, I think. Yep. And here we go. So also here, now data, what has changed? I can see main has 0 and I have AS8220 and change that. Okay. And now if I go to checks, I will see the checks are running, still running. And if I look into it, it failed. And what it failed is that ATL1 edge 1 via as can reach JFK1 edge 1 can reach it, and hence we are not allowed and the check fails. So if I want to merge this, actually the check should fail now, and if I want to merge it, I will not be able to merge it because this check failed. And me as the network engineer, as Chloe, will need to fix this before I can merge it into main. All right, so that is when the rules are defined accordingly, and that's how it's supposed to be. So now let me show you how easy it is to add another rule, just for the sake of simplicity. Now I'm going to log in as an operator, a network operator, with the admin capability. And what I will do also here, I'm a good network operator, creating a branch with the name, let's say, admin Titan depth. And here I'm going to do a reachability rule where I say, let's take the device again. Let's take just device for the sake of simplicity, and let's take H1. And now I'm going to be a little bit cheeky, because what I'm going to do is to say I as a network operator decided that I want to have a new GFK rule. Okay, hop count 1. Okay, and that is just for the simplicity. I'm changing that depth to 1. Now, here I actually have a little bit of a conflict because one has max depth of 3 and the other one is 1, but the automation figures this out automatically, and there will be 3 checks. One will be true, but the other one will be wrong, false, right? And let's check that out. So if I create a proposed change now with the admin, and let's call it admin tight, and let's call it, I don't know, let's give it also a nice name so we see this later, like something like that. Now the data has not changed that much. In this case, I added a rule. This is true, and this is what you can see here. But I did not add I did not change the network topology as such. I just added a new rule. So there was no change on the existing data. But now I should see, what you should see then is that one of the hop counts is on no path between, there's no path between ATL1 and edge 1, JFK1. And hence now it failed accordingly. And the other checks are okay. So yeah, this gives one the ability to do dynamic rule changes and immediately after see that it takes effect on the checks accordingly. So now let me go back to the presentation. Based upon this capability, you have the options to do all those use cases and even more. If it is firewall compliance, if it is latency, if it is change of impact assessment, maintenance, dependency blast radius, path redundancy, tenant and zone segmentation, continuous appliance, and so on, right? And with this rule set that defined this schema, the ability to create a schema that a check can use to then, with the path traversal, to take the data and the check to create reachability check. This is the powerful of Infrahub. You do not need anything outside, and there is nothing that needs to be done to have this. You can have it today by just modeling the schema, the automation, and that is it. So what did we talk about today? So first of all, the basics of Infrahub. Where does Infrahub fit in the NAV framework? What it actually does in a nutshell. Path traversal, one regarding dependency and the traversal itself. Reachability checks, how we use the path traversal in checks in the automation way without the need to be an automation engineer in that kind of sense. You define it once, you define rules as an operator, you can define as many rules as you want, and the automation kicks off, it checks against it, and then not just covering the the one use case, which is in this case ASN, but it could cover all the use cases. Now, my plan is to publish this reachability schema in a repository in some time. I'll need to do some changes and some tweaks, but hopefully this demonstration already showed you the capability of Infrahub and what we can do in product. And if you want to get an update regarding when and what I'm going to publish, please join our OpsMill Discord. Make an appointment with me if you want to. Join my LinkedIn connections. And I'm happy to give you a more detailed kind of presentation and demo around this in intrinsics around even on the automation piece, what I have done to make this work in Infrahub as such. I hope you enjoyed it and thank you very much for tuning in.